Hello everyone and welcome back to another Overclocking Basics video, and this is sort of part 2 to the power limits video, because I felt like I redid it once because I forgot to mention that increasing the power limit affects the GPU boost algorithm, which is basically the entire reason why you should increase it. I was so focused on the hardware part, so yeah, had to redo that. But even after redoing it, I felt that just like putting down some things on a tablet didn't really show what happens if you mess with the power limit. So this here is a practical example, just like with the Silicon Lottery one. And yeah, we are at the test bench right now. I do have the Zotac 780 Ti in the system, that's a reference card. And this is running the Valley benchmark right now. This is a static scene, so we don't have any fluctuating loads or something. And you can see we are at 1084 megahertz. And you can also see here there's no overclock in there, it's just a custom fan curve and nothing else. And then we also have GPU Z, where we can see our power readout. We are consuming a steady 230 watts, and that's about 92% of TDP. And yeah, so if you now take the power limit and increase it to max, we see that actually nothing happens, because the max of this card, this being a reference card, it has a very, very low extra power limit, just 6%. And you can see our power consumption hasn't changed. We are still at around 230 watts. So this is because, well, this card is not really the best example if you want to increase the power limit, but we can still show the functionality of it. We just have to trick it a bit. So let's just pretend that 80% is our base for the power limit. If I apply that, we see immediately our clock gets lower, our voltage drops, and we are now at around 200 watts. And this is the power limit in action. So this being a 780 Ti, the GPU boost algorithm on this is rather basic, so this clock will pretty much stay the same, except the card gets significantly hotter, which it likely won't. The fan curve is pretty aggressive, you can probably hear the card. But now you can see this is the power limit, because before we were at like 92%, we were actually not hitting the power limit. Like if I go here, we see VREL, and VREL just means the voltage is at its max, and we could just increase the voltage, which it won't do if we are power limited. So if you go back to max, we are still at VREL, but we have higher voltage now. And yes, we actually boosted a bit higher now. We are at 1098, not 1084 as before. So the GPU boost algorithm here also factors in temperature and voltage and all that. Just on newer cards, you can't adjust, like this voltage slider won't actually change the voltage anymore. It just will tell the card you can stay at the highest voltage for longer, whereas here it will actually increase the voltage. But back to the power limit, which this is about. If we go all the way down to 60%, we will go down to 700 megahertz. And yeah, we see here we are power limited. We are at pretty much the 60% and around 144 watts. And if we say, let's just pretend 60% is 100%. If we now increase the power limit, like we haven't changed any overclocking things here, like core clock, memory is still +0. We haven't changed, we haven't touched the voltage slider. We just increase the power limit, and well, the temperature limit increases with it because these are connected together. But power is given priority, as you can see here. If you now increase the power limit and just click accept, we do nothing but change the power limit. Our voltage goes up and our clocks go up. And now on newer cards, if the card should decide we can push a bit more voltage, the clock will increase again. But as I've said before, on newer cards you can't manually change the voltage anymore. The newer cards regulate the voltage by themselves based on how far away you are from the power limit, how hot the card is, and all that. It's a pretty complex algorithm. I just chose to use this older card partly because I don't really have any newer cards to mess with right now. And also because the older cards are more simpler to explain, because there's less stuff going on and they still have the same power limit functionality. So that's like, yeah, this wasn't really intended to be a long video, this is just a demonstration. Like, by nothing but changing the power limit, we can get extra performance. So like, if we are at 100% and increase the voltage, we should jump up. Yeah, you see, we are at the 100% and, well, it's cut off there, but it says power there. You can see there's green now, which means power limit. And we jumped up to 200. Yeah, we got 15 watts more with the extra voltage. And yes, we did get some extra clocks, but because we just increased the voltage, the card is getting hotter. You see we are at closing in on 70 degrees. If it gets hotter, the clock will go down again. So, yeah. But yeah, that's just the demonstration. The power limit does affect performance. And yeah, so max that power limit, because you can see 40 FPS, max power limit, 63, 65. That's a pretty extreme example because, well, I dragged it down all the way. But again, this card only has 6 extra percent. Most other cards have around 20% extra if they're not super cheap. And AMD cards can do plus 50% sometimes. So yes, AMD cards are pretty extreme. AMD cards can also still set a static voltage while NVIDIA cards can't. But yeah, that's the video I wanted to make. That's just, well, a practical example of what I was trying to explain. And yeah, hope you enjoyed watching the video, and until we see each other next time. Goodbye.